RF Maker. Build radios and listen to the world.
Hello and welcome to the RF Maker channel. This is Hotel Alpha 1 Charlie X-Ray and the operator is Leslie. In this short video series we are going to explore the making of crystal radio step by step from theory to practice. Unfortunately, in many cases building a crystal radio doesn't work out well on the first try and this can easily discourage beginners. But don't worry, in this series we'll go step by step so you can understand how it works and make sure your own build will be successful. This trip will be a great introduction to the world of radio. One of the most important things is to understand what amplitude modulation is and how we can demodulate the AM signal. The key component in this topic is the diode, also called the envelope detector. The first video of this series will show you the theory of demodulation with the help of the LTSpice simulator. If you don't know LTSpice, please check the Analog Devices website. There you can find plenty of information about the software and you can also download it. Let's go! I prepared two signals to create the AM signal. Let's check them out. The first voltage source component is a sinus generator with setup of 514 kHz signal frequency and 1 volt peak signal level. That is the frequency where you will tune your radio in real life. The second voltage source represents the information, the speaker's voice, music or even a Morse message. In this case it will be a simple 1 kHz sine wave, which sounds like a beep. So 1 kHz sinus wave, 0.7 volt peak signal level and 1 volt offset level. And now we need one important component to mix the two signals. It's called arbitrary behavioral voltage source. What can we do with this? We must multiply the two signals together. So we do it. V carrier times V beep. Let's take a look at the signal shapes. The first signal is the carrier. I will zoom in. Yes, this is a sine wave signal. Check the frequency with FFT tool. Okay. It's really 540 kHz. The second signal is the modulator, the beep signal. Right now, I don't need the zoom in. I check the frequency. Yes, it's really a 1 kHz signal with 1 volt offset. And finally, let's take a look at the AM signal. And works fine. Let's examine the AM signal a little closer. The information content is really in the change of the amplitude. This red line is the 1 kHz signal. What happens if I change the size of the offset? Let's set it to 0.5 volts. This is an overmodulated signal. If I increase the offset, then the signal will be undermodulated. In practice, it's good when the offset level of the modulator signal is the same as the peak voltage of carrier signal. And the amplitude of the modulating signal should be at least about 30% smaller. So the question is now, which components are needed to demodulate an AM signal? One diode. It's a good choice if the diode is a germanium diode because it has a lower forward voltage. I'm loading the parameters of a germanium diode. And now I put the capacitor. The value is 22 nanofarad. And finally, a high impedance speaker as the load. I make the connections now. And ready. First, without explanation, let's take a look at the demodulated signal. Okay, it's worked very well. The input signal of the even lobe detector was an AM signal, and the output is the information, in this case the beep. Now we can explain the parameters. For example, why do we need to use a 22 nanofarad capacitor, or what does the diode do? So let's start. Simply speaking, the diode lets the positive part of the AC signal pass through, but blocks the negative part. Check it out. We can see the negative part of the signal is lost. It's worked well. Okay, but if I don't have a capacitor, then what happens? I delete the capacitor. The envelope disappears and only the short pulses of the carrier remain. So the capacitor and its value are very important for demodulation. And why doesn't it work with a modern 4 or 8 ohm speaker? Because the RC time constant must be long enough to fall off the envelope. Because the detected signal level is very small and the low impedance load would absorb too much energy. The RC time constant, that is the most important topic in envelope detection. You can see this practical formula. Let's calculate this on paper. You can see the 22 nanofarad capacitor works well with a 4 kilo ohm load. Thank you for watching. See you in the next video where we will try it out in practice. If you liked the video, please subscribe.